Good morning, class. Today we are doing with a topic which is slightly tricky. The topic's name is Lanthanoid contraction. So today we will study about this and we will try to cover important pertinent points like what is lanthanoid contraction first of all. What is lanthanoid contraction? Post that we will study why lanthanoid contraction. And in the last, we will talk about what are the various consequences of lanthanoid contraction. So we'll do one by one. So any child who want to suggest what is lanthanoid contraction? So what is lanthanoid contraction? Lanthanoid contraction is, as you can see here, lanthanoid contraction is lanthanoid elements, if you can tell me, they are expanding right from cerium 58 to lutetium 71, right? Lutetium 71. So as one moves from left to right, this is atomic number plotted against ionic radii. So as one is moving from cerium 58 to lutetium 71, there are three positive ions. The size is gradually decreasing. Size is gradually decreasing. So this gradual decrease in size, the gradual decrease in size as one moves from cerium 3 plus ion to lutetium 3 plus ion, this gradual decrease in size is known as lanthanoid contraction. So I would repeat, this is steady or smooth decrease in size of lanthanum 3 plus ions as one moves from cerium 58 to lutetium 71 is known as lanthanoid contraction. So hopefully I have answered the question, what is lanthanoid contraction to you? So if you want to repeat, you can repeat that. As one moves from cerium 58 to lutetium 71, cerium 3 plus ion and lutetium 3 plus ion, the size is gradually decreasing. This steady decrease in size of lanthanum 3 plus ions is known as lanthanoid contraction. So hopefully this is done. Now we will move to the next part of the topic, which is why lanthanoid contraction is taking place. Why lanthanoid contraction? The next point is why lanthanoid contraction. So as I may ask you, the electronic configuration, the general electronic configuration of a lanthanoid element. So general electronic configuration, it is can be written as n minus 2 f, number of electrons is x, n minus 1 d, number of electrons is y, and n as number of electron is z. So it can be written as 4fx for lanthanoids in particular, and then 5dy, and then 6sz. So what is happening? This is the general electronic configuration for a lanthanoid element. What is happening is, if you can go into this diagram, what is happening? This is the nucleus. We agree? And then this is 4f energy level, this is 5d energy level, and this is 6s energy level. So this is point number 2, different energy levels. Point number 3, as the atomic number increases from 58 to 59, you can see the increase. So what happens to the number of proton? Number of proton increases in the nucleus. Number of proton is increasing here. And where does the last electron entering? The last electron, as a matter of fact, is entering into 4f energy level. So electron is coming, the last electron is coming here. So now what happens? As the number of protonic charges are increasing, the attractive influence of these nuclear charges for the 6s electron is also increasing gradually and very prominently, because the shielding ability of f orbital is very poor. As you know, the order of shielding ability is s, then p, then d, then f. What is shielding ability is an important part of the whole discussion. We may discuss it sometimes in the future. So the shielding ability order is this. F electrons are very poor shielders. So the attractive influence of the nucleus for the outermost electron is increasing gradually. So what happens? What is the impact on the size? The size contracts, the size decreases. So why lanthanoid contraction is because of this reason. So if you want to go into the writing part of this, why lanthanoid contraction is happening. So reason of lanthanoid contraction you can write here as atomic number increases, that's written very clearly, as atomic number is increasing, the electron is going into 4f subshell. As I told you, 4f subshell causes very inadequate, ineffective screening impact. This is point number two. And point number three, there is a gradual increase in the nuclear charges also. So what happens? The force of attraction between the nucleus and the outermost electron is increasing. The electron cloud shrinks, getting attracted towards the nucleus, and this results into the gradual decrease in size. So why lanthanoid contraction? Hopefully I have explained you. So quickly note it down why lanthanoid contraction. So quickly note it down why lanthanoid contraction is happening. You have to keep on mentioning three important facets of this discussion. The electron is going to 4f subshell. Point number two, F subshell has very poor shielding ability. And point number three is the attraction for the outermost electron cloud is gradually increasing because there is a gradual increase in number of protons. So this in combined causes a gradual decrease in size of elements as one moves from left to right, from cerium 3 plus ion to lutetium 3 plus ion, size is decreasing, and this is the reason. So this is why lanthanoid contraction. Now the last portion of our discussion is what are the consequences of lanthanoid contraction. The consequence number one is, which is important, consequence number one is the atomic radius of zirconium and hafnium. The atomic radius of zirconium and the atomic radius of hafnium, they are rather almost same, 160 and 159 picometers. Zirconium is belonging to second transition series and hafnium is belonging to third transition series. You can see here this is second and this is third transition series. So what I want to say is zirconium and hafnium belong to second and third transition series, and the consequence, the most prominent consequence of lanthanoid contraction is that the sizes of second and third transition series elements are getting very comparable. They are almost similar, not same exactly, they are similar, they are comparable. So this is a direct consequence of lanthanoid contraction. How you want to know? So what is happening? Atomic radii of second and third transition series elements are comparable as the reason now why they are comparable, as the increase in size on moving down from second to third transition series is exactly compensated by lanthanoid contraction. So why the sizes are becoming comparable? Because whatsoever increase in achieved as one moves from second series to third series is exactly compensated by lanthanoid contraction. So the increase in size is compensated by lanthanoid contraction. So sizes become almost comparable. So note it down. This is tricky. You have to note down, you have to discuss and rediscuss, and then if you want to crisscross, you can crisscross me always in the chat box or WhatsApp separately. So why the sizes are becoming comparable? This is done. Next consequences, as as the sizes of various lanthanoid elements are same, comparable, so their properties are also similar. And when their properties are similar, you can simply understand when the properties are similar, it becomes very difficult to separate them. So separation of lanthanoid is a very difficult proposition because their sizes are comparable, their properties are comparable. So this is consequence number two. And the last portion of the whole discussion is that as the basic strength of different hydroxides, rather trihydroxides, because it shows a valency 3. So the hydroxides of cerium and hydroxide of lutetium as one is moving from left to right, from cerium to lutein, size is decreasing. So as size decreases, you know that the covalent character has to increase, courtesy Fajon's rule. And as covalent character increases for lutein hydroxide, what happens? The acidic nature increases. Acidic nature increases means what? The basic nature decreases, basic character decreases. So if I may ask you, out of cerium hydroxide and a lutein hydroxide, which is more basic, rather the most basic, so answer is cerium hydroxide is the most basic, lanthanoid, and lutetium hydroxide is the least basic hydroxide of lanthanoid series. So these are the three prominent consequences of lanthanoid contraction. What is consequence number one? The sizes are becoming comparable for second and third transition series. Consequence number two is separation of lanthanoid is a difficult proposition because their sizes are very closely placed, so their properties are also similar. And what is consequence number three is as one move from cerium hydroxide towards lutetium hydroxide, the basic strength of hydroxide decreases gradually and gradually. So this is all about lanthanoid contraction. So thank you all. Thanks everybody.